Good day, students. I am Awire, your chemistry teacher for SS3. Today, we intend going through your lessons on organic chemistry. But this time around, we'll concentrate on the alkanes, alkenes, and alkynes. Because by now, you ought to have started your SSC work precisely, but we'll go over some of the things you have been taught. Because due to the nature of organic chemistry that is very volatile, some of the things you thought you have internalized, by now, we want to bring them to you so that they'll be more vivid. At the end of the lesson today, we tend to cover the following. You'll be able to draw structures of named hydrocarbons, name compounds using the IUPAC system of naming, and also to identify isomers. You recall that we have treated alkanes, alkenes, and alkynes as different homologous series. Alkanes conforming to the general molecular formula CH2n+2, alkenes conforming to the general molecular formula CH2n, while alkynes CH2n-2, where N is the number of carbon atoms per molecule. Alkanes, alkenes, alkynes, and cycloalkanes are hydrocarbons. Which are hydrocarbons mean compounds containing carbon and hydrogen only. Each of these form their separate homologous series. You remember homologous series, we said that a group of organic compounds having a common general formula, or in which each member differ from the next by CH2 or a factor of 14 mass units. Hydrocarbons may be saturated, that's containing only single bonds between carbon and carbon atoms bonded to the maximum number of hydrogens, or unsaturated, containing at least a double bond between the carbon atoms, either a double bond or triple bond. You can see the structures of the compounds here. Saturated hydrocarbons contain only carbon-carbon single bonds. Remember, it's required by now that when you are drawing structures, all bonds must be shown. You can see from the one there for ethane there, the carbon-to-carbon bond here is single. Unsaturated hydrocarbons, on the other way, you have ethane there and ethyl. For the ethane, you have the carbon-to-carbon double bond. Then the ethyl there, you have carbon-to-carbon triple bond. Also, aromatic hydrocarbons have the benzene ring structure, where you have the unsaturated structure as well. Now, let's start with alkanes. In naming hydrocarbons or organic compounds, we start from the simplest and we'll move on to the complex one. If you can understand the naming of alkanes, then others will flow from there. They were previously called paraffins. These are a group of saturated hydrocarbons that conform to the general molecular formula CH2n+2. They form a homologous series. Straight chain alkanes have their carbon atoms bonded together to give a single chain. Alkanes may also be branched. Now, let's go on to the naming, which is quite tricky. In naming, we realize that one, the names are based on the type of carbons, the side chains, and the position. Most of the names will be ending in ANE for the alkanes, ENE for alkene, and YNE. The number of carbon is given by a prefix. We recall that the first four members of the alkane homologous series, they have their generic name, the methane, ethane, propane, and butane. But from the 5th member to the 10th member, they take their Latin prefixes. Penta, supposed to be for 5 carbon atoms, hexa 6, hepta 7, 8, octa, 9 nona, 10 deca. For example, at the end of each, you have the suffixes that will tell you the name of the particular homologous series we are dealing with. In naming, the first thing you ascertain is to determine the longest continuous chain. Most of them are not always straight in the molecule. The examiner can decide to confuse you by bending it somehow, but you look for the continuous chain that is longest. The base name of the hydrocarbon, that's the backbone, is the name of the longest chain. Look at this structure, for example. You have 6 carbon atoms, but if you look at the longest possible chain that is continuous, you have 5 carbon atoms. And you notice that there's a branch of a particular carbon. The system of naming recognized the world over is the IUPAC system, that is International Union of Pure and Applied Chemists. We name any branching of the longest chain as an alkyl group. Alkyl group are alkanes that have 1 hydrogen atom less. They don't stand on their own. They have to branch off a particular main chain. The complete name of a branch requires the number that locates the branch on the longest possible chain. Therefore, number the chain in whichever direction gives the smaller number for all branches. You see this shortly. Look at the structure that I showed you on the other slide. You have the carbon atoms numbered, and the longest possible chain you can have will be that which contains 5 carbon atoms. So you number 1, 2, 3, 4, and 5. If you decide to number from your right to the left, you find out that where you have the branch will be in carbon number 4. But if you number from left to right, the branch will be on carbon number 2. And like we said in the previous slide, you have to take numbering that has the least. So 2 is less than 4. So this is the correct numbering. When 2 or more branches are identical, we use prefixes such as di, tri, or tetra. For example, the compound dimethylhexane presupposes that you have 2 branches on carbon number 2 and carbon number 4. But because you have the same, or the branches are identical, we are using that prefix di. Should we have 3, it will be tri, 4, tetra. Prefixes are ignored when determining alphabetical order. For example, if you have different kinds of branches, like the compound 2, 3, 5 trimethyl, 4 propyl heptane. The 2 branches there are the propyl and the methyl. You have 3 methyl, that's why we call them tri. But because M comes before P in the alphabetical order, the prefixes will be arranged in such a way that methyl will come before the propyl. Look at the next one. When identical groups are on the same carbon, repeat the number of the carbon in the name. For example, 2,2-dimethylhexane. 2,2 indicates that the carbon number 2 has a methyl, has 2 different methyls. Again, we don't just say that dimethyl. We have to name the carbon atom having those methyl groups. Where there are 2 or more different alkyl branches, the name of each branch with its position number precedes the name. Like before the main skeleton, the backbone, it has to be preceded by the alkyl branches. The branch names are placed in alphabetical order, like I said before. Now, in naming alkenes and alkynes, there's a slight difference because both groups are unsaturated hydrocarbons. Each group is a homologous series on its own. We know that the alkenes, like I said, they conform to the general molecular formula CnH2n, while the alkynes, they conform to the general molecular formula CnH2n-2. The main chain is defined by the chain containing the greatest number of double or triple bonds. So if you have, unlike the alkanes where we identify using the position of the branch, here what matters is where you have the double bond or the triple bond placed. We number the position of the double or triple bond so that it has the lowest numbers. Alkenes generally contain carbon-to-carbon double bonds. Like I said, the general molecular formula to which they conform is CnH2n. And the suffixes common to the alkenes is ENE. So they all end in ENE, whether it's ethene, propene, butene, etc. In the carbon-carbon double bond, 2 pairs of electrons are being shared, leaving the carbon free to bond to 2 other things. Yeah, what I mean is, since each carbon atom has a valency of 4, after forming a double bond with 2 electrons are left. So any carbon that has a double bond can only formulate 2 other bonds, like you have in ethane there and propane. Alkynes, on the other hand, contain carbon-to-carbon triple bonds. They conform to the general molecular formula CnH2n-2 for 1 triple bond. The nomenclature system for alkynes is identical to that of alkenes, except the suffix YNE is used to indicate the position of the triple bond. Look at the compounds we have here now. The first one is ethyne, where the carbon-to-carbon bond, you have triple bonds there, and this carbon atom can only form 1 other bond after forming the triple bond. Look at the next compound there. That's butane or butanine. Again, the numbering has to be such that the least number of carbon atoms is assigned priority. Look at the second compound here, where you have about 2 possible continuous chain. We'll take the longest possible chain and assign priority to the side that has the least number of carbon atoms. Now, we'll attempt to name some of these compounds and we'll follow a set of rules. Look at the compound whose structure is given here now. You see the arrow pointing to the double bond. That's where you assign priority. So in naming this compound, there are different possibilities, but only one correct way. It's either you name it such as you have 7 carbon atoms in the continuous chain, then you will not ignore the priority that's supposed to place on the carbon double bond, or you assign priority based on the carbon-to-carbon double bond, and you now have the longest possible chain having 6 carbon atoms. So the first thing, you identify the correct functional group, which is the double bond. Next, you find the longest possible chain. You can see the one I've circled here now. That is the longest possible chain, starting from the double bond and ending there. Now, after finding the longest possible chain, the next thing is to add the prefix, naming the longest chain. So, you see the longest possible chain there, you have 6 carbon atoms. So, it has to be hex. Then you number the longest chain with the lowest number closest to the double bond. Now, we start numbering from where the double bond is. See the numbering now. Carbon number 1, 2, 3, 4, 5, and 6. That presupposes that you're going to have 2 methyl groups on carbon number 4 and an ethyl group on carbon number 2. You can see the name now. You have ethyl, methyl, and methyl. Like we said before, when you want to name them, you assign priority based on the carbon double bond. Then, in naming, the number of that carbon having the substituent or the alkyl group has to be mentioned. Here you have carbon number 4 having methyl, methyl. So since you have identical alkyl group on carbon number 4, it's going to be a dimethyl, both on carbon number 4. So I'm going to have a 4,4 dimethyl. But in the name, E comes before M. So in writing the name, we're going to have an ethyl group on carbon number 2 first before the 4,4 dimethyl. Then we now have the hex 1N. I'll go over that again. So I'm going to have 2 ethyl, 4, dimethyl, hex, because you have 6 carbon atoms, hex 1N, or if you can say hexene. I said that you place them in alphabetical order and name the compound. So what was the name of the compound? It should be 2-ethyl 4,4-dimethyl hexene. Now, before the next class, I want you to just practice by attempting to name the following compounds. The instructions have been given. And you put into practice all you've learned today in assigning priority, naming the carbon atoms, numbering the carbon atoms, identifying the longest possible chain, then writing the name, taking into consideration the alkyl groups, the position. And when writing the name, write the substituent in alphabetical order. You take that and also this. It's important that you practice. At the end of this particular class, I will give you a number where you submit your assignments to, and we can interact. If you have any problem, I will attend to you one-on-one based on your level of difficulty. This is also another one to practice. The only way you can be proficient is by engaging in multiple exercises. Then lastly, this. Again, don't just ask for help without attempting them. Attempt them first. Wherever you are stuck, you can let me know, then we'll treat them. Please submit your assignments with your name, your class. Don't just tell me that you're in SS3, SS3A or SS3C, G, H, or so. Attach a phone number that I can reach you with. The phone number there is mine. You can reach me through WhatsApp or Telegram. We'll continue from there in the next class. Till then, God bless you. Stay safe.